Hi there, this is Lab 2-2, Series Circuits Voltage Relationships. The purpose of this lab is for us to demonstrate that regardless of the loads that are connected, the sum of all voltage drops will then equal the source. In other words, whatever is being dropped across this light bulb, plus that one, plus that one, plus that one, plus the cone heater, all have to add up to the sum of the source, okay? If we create an open in any series circuit, then we expect that current will not be able to flow, okay? If we have a closed series circuit and all of our loads are good, then that would mean that current can flow through the circuit. Now, it's also important to note that the amount of voltage at each load will not be the same if the loads themselves are different, as is the case within this load. So in your diagram, in your Lab 2-2, I've connected up the circuit from figure 1. So I have a 60 watt light bulb here. I have a 100 watt light bulb there, a 150 watt light bulb there, a 200 watt light bulb there, and then our cone heater up top there, okay? I've got a meter here connected up. I'm going to use these mobile test leads to be able to determine the voltage drops across the loads. And then I've got another fluke meter down here that is connected up across the source as per the diagram in your book. Okay, so step number 4, they ask us to turn the power on and increase it up to 120 volts. So let's see if we can get that. All right, so we're going to increase this voltage up to 120 DC. We're at little over 120 there. It's going to fluctuate up and down a little bit here. We're pretty close to 120. Okay, so you can see that we do have a couple light bulbs glowing, but these ones are not glowing. That does not mean that the circuit is not working. Okay, what that means is that there is more voltage drop occurring at these first 2 light bulbs than there would be at any of the other ones, okay? So if one of these light bulbs were bad, such as if I unscrewed this one, you can see that that opens that circuit up and prevents current from flowing. So I'm just going to screw that guy back in. So that's always a trick that I have my students in class. I always ask them, you know, you guys must have a bad light bulb there because it's not glowing like these ones are, and then everybody goes and starts unscrewing light bulbs and figuring things out. So they ask us for load number 1, which happens to be the 60 watt bulb. We are then going to meter and see what the voltage drop is across that. And you can see that that is sitting around 70 volts. Okay? And my voltage drop across this guy here, the 100 watt bulb, is 27 volts. Okay, so I'm just going to record these as we go. We've got 70 volts for the first one, load number 1. Load number 2 is 27 volts. Okay, load number 3, we've got almost 12 volts, 11.8. I'll call it 12 volts. I'm just going to try to keep numbers fairly rounded here. Okay, across the 200 watt light bulb, which is load number 4, we've got 5 volts. And then that would mean that our cone heater here should see the remaining voltage drop across it, which happens to be 7.7 volts. Okay, so if we added this one up, plus the 200, plus the 150, plus the 100 and the 60, we should see our source voltage. Okay, so you guys can check that on your own. I know I've rounded things so it might not be exact. Okay, then they ask us to turn that down to 0. Power down. Short circuit load number 4. I'm on step number 7. So load number 4 happens to be this big 200 watt light bulb here. They want us to short circuit it. Now that means basically what we're going to do is we're going to apply a jumper from that terminal to that terminal. And what that is doing, if you recall, current will take the path of least resistance So because we have this jumper in place, it's going to prevent current from flowing through that light bulb. It's going to bypass through the red jumper that I just installed. Okay, so we're going to turn this up. What do we anticipate to happen? We anticipate that the voltage drop here, as I get up to 120 again, the voltage drop that was at load 4 from the previous discussion, which was about 5 volts, that is no longer present there, so that we would then see an increase of voltage being dropped across far more of the other loads here. So if we re-record these guys, my 60 watt light bulb, load number 1, is sitting now at, whoops, I'm looking at the wrong meter, sitting at 74 volts now. So he's up about 4 volts. My load number 2 is at 29. So 74 and 29. Okay. Load number 3 is getting 13. And load number 4 is my bypass one. This should be near 0, which it is. And then my cone heater load number 5 is sitting at just below 8 volts. Okay, so now we're at step 10. I'm going to power down. They ask us to remove the short circuiting jumper. Okay, and then remove the jumper between load 3 and load 4. So this is load 1, load 2, that's load 3. So between 3 and 4 is that jumper. I've taken that out. Okay, turn the power on, and then we're going to meter the loads. Now, I've created an open circuit here. So I would anticipate that all of these loads should be 0, with the exception of the voltage drop between that point and that point. I should see my source. Okay, so I've got power on again. You can see I've got, ooh, we're up a little bit here, 128. Let's go down. It really fluctuates on this power supply. Okay, pretty close to 120 there. Maybe turn it down just a hair. 119.8. Okay, so remember, I should see 0 here, which I do. Should see 0 across load 2, which I do. Cross load 3, I've got 0. Load 4, I've got 0. Load 5, I've got 0. Okay. So we've got no current flowing in here, so no voltage drops across it, but across the open we should see our source, which we will. We've got 119 volts. We're actually dropped down a couple volts or a volt again. So that voltage up there matches what's going on down here. I can adjust that up and down. Now we're sitting exactly at 120, so these 2 meters match. Okay? So the voltage drop across any open in a series circuit, provided that the remainder of the loads are okay, will always equal the source. Okay? So I think that's probably the end of those steps. Yes, it is. Now after this, we will get into the observations and conclusions within our online discussions. So that was Lab 2-2, Series Circuits Voltage Relationships. Thank you.